In this video, I'll be explaining to you how oxidative stress is involved in the pathogenesis of atherosclerosis. I have explained atherosclerosis in context of coronary artery disease, in which there is build-up of plaque in the artery that supply blood to heart muscles. Atherosclerosis is a general term that refers to the build-up of plaque in medium or large-sized arteries. Atherosclerosis is a chronic inflammatory disease and is characterized by the accumulation of lipid, inflammatory cells, calcium and fibrous tissues along the inner walls of the arteries. Large number of studies has found involvement of reactive oxygen species or oxidative stress in atherosclerosis initiation and development. As has been discussed earlier, that oxidative stress is an imbalance between reactive oxygen species and antioxidants. This imbalance is in favor of increased generation of reactive oxygen species and or reduced antioxidant defense system, that is the reduced level of glutathione peroxidase or impaired activities of glutathione peroxidase, catalase, superoxide dismutase, or the reduced levels of glutathione, reduced glutathione, vitamin E or vitamin C. Though I have explained atherosclerosis in detail when I was explaining the coronary artery disease, but I'll enumerate it once again. This figure is showing various layers of blood vessels such as endothelium, tunica intima, tunica media and tunica adventitia. These layers have also been mentioned while discussing coronary artery disease. Normally, blood flows through the vessels without anything being anchored to this endothelium. But when there is oxidative stress or when there is increased generation of reactive oxygen species, what it does, it causes the oxidation of low density lipoprotein, and it can also cause damage to endothelium. In addition to that, high level of native LDL in the blood may also play an important role in the development of atherosclerosis. Normally, the endothelium do not express these cell adhesion molecules. But when there is build-up of low density lipoprotein or when there is high level of oxidized LDL or when there is a damage to endothelium, what happens? It causes the increased expression of cell adhesion molecules on the surface of endothelium. The increased expression of cell adhesion molecules on the surface of endothelium causes the recruitment of leukocytes, monocytes, neutrophils, T lymphocytes and mast cells. And then they migrate to tunica intima, followed by their migration into tunica intima. Once the monocytes reaches tunica intima, they differentiate and mature into macrophages. What is unique about the macrophages is that they express scavenger receptors. And because of the expression of the scavenger receptors, they very efficiently engulf or take up the oxidized low density lipoprotein, and by the ingestion of oxidized low density lipoprotein, they become foam cells. They call foam cells because of their appearance. They are named foam cell because the lipoproteins, they give the macrophages a foamy appearance. The presence of foam cells in the arterial wall is a hallmark feature of early atherosclerotic lesion. Like the monocytes, leukocytes, mast cell, neutrophils, T lymphocytes, they also migrate into tunica intima. And along with the foam cells, all these cells causes the release of variety of cytokines that promote inflammation and the generation of reactive oxygen species. In addition, these cells releases growth factor. Growth factors released by T lymphocyte, mast cells, neutrophils, leukocytes and foam cells along with the reactive oxygen species causes the differentiation and migration of smooth muscle cells from tunica media to tunica intima. This is accompanied by increased synthesis of collagen that causes the hardening of the atherosclerotic plaque and collagen deposition, leading to the development of erythematous plaque. During this process, these foam cells, they die and causes the plaque to grow. Rupture of the plaque lead to the formation of thrombus.